This is Geometry, Lesson 9.5, Dilations. This is the second half of the lesson. We're going to talk about being able to understand dilation images of figures. Remember, a dilation is not an isometry. It does, in fact, change the size of a shape. We talked about that a little bit before. So, earlier yesterday, we looked at a dilation of a figure drawn in the coordinate plane. Whenever in our curriculum, whenever we talk about dilations of figures in the coordinate plane, we're going to always say that they have the origin as the center of dilation, okay? So you can find the dilation image by multiplying the coordinates of your ordered pair by a scale factor, just like they did right here. So here they have their original ordered pair. Here they found their image by taking those x and y values and multiplying them by that scale factor. So that's what we're going to do here. It says finding a dilation image. What are the images of the vertices for a dilation with center at 0, 0 and scale factor of 2? So just think about that for a second. If your scale factor is 2, it means it's bigger than 1, which means this is going to be a bigger shape. Okay, so we're going to graph PZG to start off with. We graph our P at 2. Make sure that you label your points as you go. We graph Z at -3, 1. And we're going to graph G down at 0, -2. Connect your dots and you've got your pre-image. And now we're actually going to graph our image right here. That's going to be our image in blue. So what we do is we're going to take that scale factor and we're going to multiply both the x and the y value by it to get for P prime 4, 0. Go graph your point, put a little dot there and a P prime. Z is at -3, 1, so that's going to go to -6, 2, and you multiply everything by 2. Here we've got our Z prime. G is 0, -2. That's going to go to 0, -4 for G prime. We graph our dot, put a little G prime, connect our dots. So that large shape is our image. Sometimes you'll see them shade it in. When the image like that is the larger shape, they'll kind of shade in that space in between the two. Okay, so there we have our image. I want you to try the same thing on the next one. Pause the video here and at least try to come up with your ordered pairs for P prime, Z prime, and G prime. I'm going to assume that most of you were able to get P and prime and G prime. A lot of students struggle with getting that Z prime because -3 and 1 result in you getting, when you multiply this by 1/2, you get decimals or fractions, and that's okay. I'd recommend putting them in decimal form so you can kind of graph the approximation of where it should be. Just go -3 times 1/2. If you type that in your calculator, you'll get out -1.5. You can use that. 1 times 1/2, type that in, you get 0.5. Now we can graph all these points. We'll graph our pre-image, P, Z, and G. P is at 2, 0. Z is at -3, 1. G is at 0, -2. And now when we graph our image, since this one has a scale factor of 1/2, it's going to be smaller. It's going to be inside there. Here's our P prime at that 1, 0. Our G primes down at -0, -1. And then our Z prime is going to be at -1.5, 0.5. So when you graph that, the -1.5 should be in between -1 and 2. And the 0.5 should be in between 0 and 1. You're going to get a point about right there. And then connect your dots. Okay, and so when that image occurs inside, they will just shade in the image. All right, so that's kind of how we go about graphing these images using dilations. Remember, both of these, the center 0, 0, the center of dilation is 0, 0, the origin. And so here they ask us to do something similar, but you're just doing an ordered pair and you're not even asked to graph them. So I want you to pause the video right here and do these next 3 problems. All right, you should have checked your answers already. D is at 2, -10, and multiplied both by 2. T is at 0, 2, and multiplied both by 1/3. And M, the origin, the center of dilation, shouldn't change. It's at 0, 0. So this is kind of your coordinate plane and point dilations, but one thing we're also going to talk about is context. So we can use dilations and scale factors in real world when we talk about enlargements and reductions, such as images seen through a microscope or a computer screen. So this first one, we've got a magnifying glass. It allows you to see an image of an object that is 7 times the object's actual size. So the scale factor of the enlargement is then 7 because it's 7 times bigger than what it was. This photo over here on the right, this shows an apple seed under the magnifying glass. If you can't read this number right here, this is 1.75 inches. Then what we're going to find out is what is the actual length of the apple seed. You have to be careful. Right now, since we're being seen it under the magnifying glass, this is our image. If we want the actual, we're looking for the pre-image. Now, we talked about an equation for your scale factor. We said n equals the ratio of something to something. So it should be the ratio of the image to the pre-image. And so when we set that up, we can plug in these things that we know. We know that the scale factor is 7. They told us that. We can put in 7 for n then. And we know that the length on the image is 1.75 inches of that apple seed. What we're looking for is what is the actual length of that apple seed, x. And so we have this equation we can solve. Now, you've solved equations like this before when we did trig. When something like this occurs, when you have x in the denominator like that, you really want to multiply both sides by x. You get 7x equals 1.75. Now we have to finish solving for x by dividing both sides by 7. Type that in, go 1.75 divided by 7, hit enter. And the length of our actual apple seed then should be 0.25. Now this is a context problem and we are talking about the length of an object, so there should be a label with it, units. Think back to what are the units they're using in the magnifying glass, and we want to continue with the same units here. Inches. It's 0.25 inches or 1/4 of an inch. Now here's another problem. It's pretty similar. This time though, they're talking about a computer. It says the height of a document on your computer screen is 20.4 centimeters. When you change the zoom settings on your screen from 100% to 25%, so you've zoomed out, the new image of your document is a dilation of the previous image with scale factor 0.25. What is the height of the new image? So think about this for a second. If we went from 100% zoom to 25%, is this a reduction or an enlargement? Okay, so now that you've decided that, let's go ahead and actually do our problem. So it says that your document was 20.4 centimeters and your scale factor is 0.25. What is the height of the new image? So the 20.4 then is our pre, and the new image is our final. So if we set this up, we have a scale factor right now. Remember scale factor, n equals length of your image to pre-image. So we know our scale factor is 0.25. We don't know how long this, how tall this document is going to be in our once we zoomed out. We do know how tall it was when we started, and that was 20.4. We want to continue by solving this equation for x. We've got this 20.4 we're dividing by, so we multiply both sides by 20.4. And we type it in our calculator, see how tall is this actual document, 20.4 times 0.25. Type that in, hit enter. And we should end up with 5.1 centimeters. Don't forget your label. Okay, this was dilations. That was the goal for today, to get you to understand images and figures. Remember, dilations change size. They're either an enlargement or a reduction. They go back to scale factors.